Hello, my name is Mark, and welcome back to the Red Planet Project channel. In today's episode, we'll talk about something that has fascinated humanity for decades. Why do we want to terraform Mars? Is it just science fiction, or perhaps an answer to our greatest challenges? Let's embark on this cosmic journey. Since the dawn of time, when we looked up at the sky, we've wondered, are we alone? Could other planets become our home? Today we'll try to answer these questions. Mars is our closest neighbor in the solar system, with a relatively short travel time of 6 to 9 months. Its similar day length, the presence of water ice, seasonal climate changes, and traces of ancient rivers and lakes make it a candidate for a new home. Mars also boasts a fascinating geological history. Enormous canyons, like Valles Marineris and the largest volcano in the solar system, Olympus Mons, are just examples of the red planet's extraordinary features. Olympus Mons, the largest volcano in the solar system, rises over 21 kilometers high. Scientists believe its gigantic size is due to the absence of plate tectonics on Mars. While Earth's tectonic plates shift volcanoes, Olympus Mons remained in one place for millions of years, allowing it to grow to its massive size. There is evidence that it may have been active relatively recently in geological terms, even a few million years ago. Some researchers suggest that magma chambers with residual heat might exist beneath the surface, which could be used for research or even future terraforming attempts. Meanwhile, Valles Marineris, an enormous canyon system stretching over 4,000 kilometers, likely formed due to the stretching and cracking of Mars' crust as the planet cooled billions of years ago. There are also hypotheses that rivers may have once flowed there, or that underground lakes existed. Structures resembling riverbeds and landslides indicate the possible influence of water in shaping this region. Some scientists speculate that Mars' crust may have experienced early forms of tectonic activity. Interestingly, Mars may have looked entirely different billions of years ago. Geological evidence and data from space missions suggest that rivers, lakes, and even oceans may have existed on its surface. Some studies indicate that Mars may have had a denser atmosphere and a warmer, more humid climate that could have supported the development of microorganisms and perhaps even simple vegetation. Rovers like Curiosity and Perseverance study ancient sediments and minerals formed in the presence of water, providing further clues about the planet's rich history. Although Mars is harsh and inhospitable, it has resources such as water ice, which can be used to produce drinking water, oxygen, and rocket fuel. Additionally, its proximity to Earth and relatively low gravity, about 38% of Earth's, make it easier to explore than more distant planets in the solar system. Mars has a thin atmosphere composed mainly of carbon dioxide. It was first discovered and studied in detail through space missions such as Mariner 4 in 1965. Mars's atmosphere, though very thin compared to Earth's, provides some protection from cosmic radiation and maintains minimal pressure, making it an essential starting point for future terraforming attempts. Its dynamics lead to the formation of gigantic dust storms that can last for weeks and cover the entire planet, posing a significant challenge for future colonists. Mars also has two small moons, Phobos and Deimos. Phobos orbits Mars in just 7.5 hours, while Deimos takes about 30 hours. In the future, they could serve as transit bases for Mars missions and logistical hubs for storing fuel and resources. Their low gravity makes them ideal for building orbital stations and logistics points supporting surface exploration. We are preparing for the future through Mars life simulations. The CHAPEA program in the USA tests how a 4-person crew copes in the isolated Mars Dune Alpha module, simulating a Martian habitat. The Mars Desert Research Station in Utah recreates daily life on the red planet, including spacewalks in suits and resource management. IICs in Hawaii studies the impact of long-term isolation on participants' psychology, while Concordia Station in Antarctica provides valuable data on surviving extreme cold and darkness, similar to Martian conditions. The modern space race is not just a competition between nations, but also an increasing role for private companies. SpaceX, led by Elon Musk, aims to colonize Mars, focusing on developing the Starship, which will enable the transport of large crews and cargo. Blue Origin, founded by Jeff Bezos, focuses on developing technologies to support long-term space missions, including systems for exploring the Moon and Mars. Virgin Galactic primarily focuses on space tourism, but its innovations may contribute to transportation technology development. We must not forget NASA's key role in Mars exploration. Programs such as the Mars rover missions, with Curiosity and Perseverance rovers, have provided valuable data on geology, climate, and potential signs of life on the Red Planet. NASA also collaborates with private companies, joining forces to send the first humans to Mars in the coming decades. Missions like Artemis aim to prepare the technologies and experience needed for further exploration of Mars. Terraforming Mars is an enormous challenge, not only technological, but also biological and psychological. Cosmic radiation is one of the biggest threats to astronauts' health because Mars lacks a magnetosphere to protect against harmful radiation. Low gravity can lead to bone and muscle mass loss, and prolonged isolation with limited contact with others can negatively affect mental health. Daily life on Mars will be challenging. Colonists will have to manage limited resources, water, oxygen, food, and rely on growing plants in controlled environments. This will require advanced recycling technologies and efficient resource utilization. Mars has long fascinated writers. In The Martian Chronicles by Ray Bradbury, Mars is depicted as a meeting place of two civilizations, human and Martian. His stories prompt reflection on our place in the universe and the consequences of humanity's expansion beyond Earth. Thank you for joining me in this episode. I hope you enjoyed this cosmic journey to Mars. What do you think will be the biggest challenge for the first Martian colonists? Share your thoughts in the comments, and don't forget to subscribe to our Red Planet Project channel so you won't miss the next episodes about the mysteries of space. See you in the next video.